All right, we're taking a look here at Kinesis Data Streams. And so here we have our nice big pipeline as a visual. We have producers that send data to the stream. We have consumers that consume data from the stream. And we have shards, which are the compute that allows us to, for our capacity for our reads and writes. And the shards are partitions. So the idea is that as you write data, you want to write data to specific partitions using the partition key. But we'll get into that here momentarily. Notice that we have compute here, just EC2 instances and EC2 instances on the right. The idea is that for the most part, data streams is very customizable, so you can do whatever you want with it, but AWS will provide code like libraries or applications to do that. Not to say there isn't direct integration to send data to your stream and to consume data, which you use data firehose to non-programmatically work with Kinesis data streams. But for the most part, you do have to have some good programming chops to use this thing. So data streams has two capacity modes. When I started using Kinesis, it only had one, which was provision, but they added an on-demand mode, which is a little bit confusing because it kind of competes with another product, but we'll talk about that in a moment. But for the use case, on-demand makes sense when you have unpredictable workloads because you're only paying for the capacity that you're using as opposed to a steady guarantee of capacity. Whereas provision, you have it's more suited for predictable workloads. For on-demand, it automatically scales. For provision, you're using customer-managed shards, so you have to specify the amount of shards that you're going to need. For billing, on-demand is based on the volume of data ingested and retrieved. Provision is the number of shards and data transfer. For capacity, for writes, you have 200 megabits per second for on-demand and 200,000 records per second. And for reads, you have 400 megabits per second per consumer. You have two consumers by default. If you need more, you can use enhanced fan-out to add 20 more consumers. For provision, you have 1 megabits per second per shard. And for reads, for writes, you have 1,000 records per second per shard. For reads, you have 2 megabits per second per shard and a max of 200 shards. So if you look at the maximum capacity provision, it's the same as on-demand. It's maximum capacity as well. The only difference between choosing on-demand is that they're managing the shards underneath. I guess the thing is that managing the shards yourself is going to be more cost effective. So that's usually the reason why you go with provisioned. What's interesting is you can switch between capacity modes at any given time. I didn't test this out, so I don't know what that experience is like, but they say in the docs you can switch between them, which is very interesting to me. On-demand kind of competes with Data Firehose because they have a similar kind of offering, though Data Firehose is very simple and has less customization. So if you need something that is simpler and you just want to have some basic transformations and deliver data to very specific AWS services, then it's going to make more sense to use Firehose. And Firehose can be used with Kinesis data streams and often is to send it to specific AWS services. So don't think that you have to implement your own custom producers. You can just send it to Firehose and then store it somewhere. But maybe if you're trying to save money, there could be reasons as to why you might want to implement your own producers. Let's talk about producers and consumers because there are a few ways that we can send data to Kinesis data streams and other things can consume data from data streams. So for producers, we have the Amazon Kinesis agent. This is a standalone Java app that will monitor files based on a pattern and send that data over to Kinesis whenever it sees any kind of changes. You have to understand how Java apps to work to deploy this. So you don't necessarily have to write Java code, but you definitely know how to run Java apps. So this is where Java becomes useful. You have the AWS SDK where you can use put records, but this is not really intended to be used for production because if you're working with Kinesis, you're working with a vast amount of data, and this is just not going to cut it in terms of at scale. Now, if you're learning how to use Kinesis, it's a great way to learn it, but for real applications, you're going to be doing something else. There's many AWS services that will directly send data over to data streams, and they might require configuration to do so. I didn't, at least when I did the labs, I didn't test for this, but AWS says there's tons of services that can do this. I think it's going to be the same list when we look at Data Firehose that can send data over there. But the idea is that AWS has its own event bus and can send data over there, or some can be configured to do so. Then you have the Amazon Kinesis Producer Library, the KPL. This is a Java-only library that allows you to scale at scale, publish data to the data stream. This is the preferred method for implementing a producer. You have to know how to use Java to do this. You have to write Java code. So this is a use case where Java becomes very important. For consumers, you can send data to third parties. So they have integrations for this. So you can send it to Apache Flink, Kafka Connect, Adobe Experience, Oracle Golden Gate, Debzian, I can't pronounce that, FluentD. So Apache Flink is definitely one that you might want to utilize. And also consider that AWS has a managed version of Apache Flink, which is the Data Streams Analytics. So that could be a great place to send your data or integrate with. Then you have Kinesis Data Firehose, and this is a great option when you want to send to a lot of services. We'll cover what those services are in the Data Firehose section, but the idea is that you can send it to Data Firehose, and they can send it to S3, Redshift, and a lot of other stuff. You can use the SDK to read records using the get records. Not for scale, so great for learning, but not for scale. Then you have the KCL library. Why they didn't call it the Kinesis Consumer Library, I don't know, but it's called the Kinesis Client Library. AWS, why don't you name these things better? But anyway, it's the client library, and it is a Java library to write your own custom consumers. But what's interesting is that it has this multi-line daemon, so it allows you to actually leverage the Java underneath in another language. So they have this for Python and for Ruby, maybe for other languages, because the likelihood of people needing to write consumers is like, you can probably get away with not writing a producer if you're using direct integration or use the Kinesis agent. You don't really have to learn how to write Java, but for consumers, you absolutely have to write code, and so they gave you more flexibility here. Let's talk about shards, and this is all for provisioning. Obviously, this is not important for the on-demand stuff. But for shards, a Kinesis data stream is a set of shards. Each shard can support up to 5 transactions per second per reads, up to a maximum total data read rate of 2 megabytes per second, up to 1,000 records per second for writes, up to a maximum total data of write rate of 1 megabyte per second, including the partition key. Each shard has a sequence of data records. Each data record has a sequence number that is assigned by the Kinesis data stream. If your data rate increases, you can increase or decrease the number of shards allocated to your stream. Then you have your partition key. So you actually have to set a partition key when you write data. So used to group data by shard within a stream. Partition keys are Unicode strings with a maximum length limit of 256 characters for each key. So basically you can call it whatever you want. You call it apple, you can call it dog, whatever you want to call your partition key. The MD5 hash function is used to map partition keys to 128-bit integer values and to map the associated data records to shards using the hash key ranges of the shards. When an application puts data into the stream, it must specify a partition key. So in practice, what I noticed is that you have a partition key. You don't say what shard it goes to, but it goes somewhere onto some of the shards. But if you only have one shard, you don't need to have multiple partition keys. You just name everything the same, okay? So you'll see me in the lab probably. I'll be naming different partition keys with one shard. It doesn't make any sense. It doesn't matter. The other thing that, well, we'll talk about this in a second, but we'll talk about sequence numbers. So each data record has a sequence number that is unique per partition key within its shard. Sequence numbers for the same partition key generally increase over time. The longer the time period between write requests, the larger the sequence number becomes. So those are your components. When I'm doing this in the lab, you'll see there's a bit of confusion for me because they'll show you like the sequence numbers and shards, and the docs don't really spell this out too much. So just understand that I'm a bit confused in the labs, and you'll feel a bit confused, but I think that once you start working with Kinesis more, it starts to make sense a bit more. We have data retention here. So retention period is how long data will remain in the stream until it's released, which is a nice way of saying deleted. Data persists for 24 hours by default. If you want, you can change that to be up to a maximum of 365 days. It's actually based on hours, but it's easy to remember a year, up to a year, okay? Additional charges for retention periods greater than 24 hours. So anyway, over 24 hours, you're going to get charged more. So if you want something longer, just look up the costs on that. The retention can be adjusted using the AWS CLI via the increased stream retention period and the decreased stream retention period. So you can adjust this. One caveat of this is that when you do change it, it's not instantaneous. It takes several minutes. So data that is already in flight going to the from producers to the stream, it's going to have that old retention period. Okay, so that is something you'll have to consider. Let's take a look at the data stream CLI, and we will definitely utilize this in the labs for learning how to write and read to the Kinesis stream. The first is put record, and notice that the data has to be base64 encoded. So there we encode it. We're providing the partition key and the stream name. If you want to send multiple records, use put records. Then we have get records, and so this one's a little bit different because you had to get the shard iterator, and that's where I got a bit confused. Because like, why do we need the shard iterator? Why can't we just read stuff? But you have to have the shard iterator, and then they have these iterator types, which I probably should have made a slide on. But the idea is that it depends on how much data you want. So it might be the last data, the last record, or whatever. And so trim horizon is what we're going to end up using. You'll see in the lab, I'll drop it down, be confused by the names. But the point is that there is iterator types. So we have that. And yeah, so that will get records. So there you go. Okay.